Hi everyone, I'm Bilal Malik and you're watching PM TechNet Learning Every Day. Today we are going to discuss about the container services. In previous lecture we discussed about one of the other compute services, which was virtual machine, and we also had a demo of it, how to create a virtual machine in Azure portal. So let's jump into Azure container instances. So basically, it's a virtualization environment, um, but it's not like in a typical virtual machine because it does not have any operating system in it itself. So they are easy to run, faster in comparison with the virtual machines, and they can be easily scaled out and can be likewise we can do it for virtual machine to schedule it for like running and stopping. We can do that for Azure container as well. So basically it's a pass offering that allows you to upload your containers, which it then will run for you. Now let's discuss this in a bit detail here, that uh, basically Azure container is an instance, and it's a service basically that enables a developer to deploy containers on Microsoft Azure public cloud without having to provision or manage any underlying infrastructure, like as I referred to virtual machine here, that unlike virtual machine you do not need any hardware, underlying hardware to run and support this Azure container service. And how it's different from virtual machine, we'll definitely discuss that in our next slide. uh, but I also would like to add some other features of ACI, are like the public IP connectivity. Let's say like a developer can expose containers to the internet with a FQDN and an IP address. FQDN, like everybody knows, is a fully qualified domain name. You can enter that and you can access that, or either you can do it from the IP address. And if we talk about some other thing, like customization is very vast. Like you can specify the number of CPU cores or memory, um, any number that developer wants to use for container instance, that can be also done. And uh, when we talk about ACS, we also talk about the Kubernetes services at the same time, because uh, the task of automating and managing a large number of containers, and how they basically interact with each other is known as orchestration. So Azure Kubernetes service is a complete orchestration service for the containers with the distributed architectures and large number of containers, you may say. So they always work, not always, like they work together. At this point, this information is sufficient. Now let's see how they're different. Right. We have this virtual machine block on the left and containers on the right. First, we'll discuss about the virtual machines, uh, the structure of it, and I'll give you some differences, high level differences between both in the analysis and the end of this slide. So definitely there would be some hardware on which or infrastructure on which will be installing having some operating system to run on, and virtual machine uses hypervisors, right? We use hypervisor, and on top of it we then build our different VMs blocks, showing it. So VM1, VM2, VM3, likewise. 3 is a bit odd, just ignore it. So we have these VMs, and what we can do here is we can have our in hypervisor, we can have our own guest operating systems. Like I can run Linux on this machine if I want, then I can run Windows here, and likewise I can run any operating system I want to run on this VM, and it all have their own guest OSs, and definitely they will be having their own libraries and binaries to run their own applications, right? And this way the virtual machine works like we specify the resources and the operating system. And why I'm saying resources, because when we configured this VM, everybody knows, like we mentioned in our previous video, while doing that we select the size of the VM, like what size we need 2 cores or X amount of RAM. So we specify the uh, cores and everything here. Now let's compare it with the containers. Containers is obviously, first of all, it's definitely going to be a hardware and an operating system, but the difference comes on this layer. Instead of hypervisors, it uses the Docker. And what is Docker? It's basically, you may say, it's a standard which is used in containers. So you can build your containers in that way, so you can have a very sufficient, efficient performance for your application in result or in comparison to this virtual machine. How? Let me describe it to you. Like uh, on top of this Docker, you can have your um, uh, different libraries and binaries and DLLs for the different applications. You can consider these as containers. It's container 1, 2, and 3. But they are sharing the same operating system. They are sharing the same operating system, right? If you see, there is no layer of operating system or guest operating system for any of the app or any of the container itself. They're basically using a single operating system to manage or to run all of these applications, and they uh, share the operating system. The host operating system is being shared. So this is what makes it a bit faster in comparison to virtual machine. So quickly, just let me give you high points to note if you anybody wants to. That hypervisor layer runs uh, for like here I can say that like for example, the way how the VMware works, hypervisor the same thing, it works the same way. Then VM contains a full copy of operating system, and it visualizes the underlying hardware like memory, storage, CPU, etc. And it also contains the application you need to run. And if you need to run uh, 3 apps or 3 different applications which need 3 separate VMs, so each with their own guest OS with certain amount of memory and the CPU. Whereas in containers, uh, it visualizes the operating system. Host could be physical or virtual server. Docker works as a hypervisor for containers, and container only contain application along with the dependencies like frameworks or binaries or libraries as it's mentioned here. And this makes a container smaller in size and faster in operations. This is what I was talking about, the Docker standard for container format, runtime for Docker containers. It's an open source project, and basically Docker is also a company that evolves that technology. Now just let's briefly touch to the Kubernetes services and benefit of it. The container management system in Azure is done by AKS. Scale out option is there on the basis of container based applications. Then you can monitor and deploy containers. Uh, in containers, sorry, in AKS, pods is a term. So basically, when there's pods, mean there's it's a group of containers, and the virtual machines are referred to as nodes. And VM scale set option is there. You can avail that, and Azure Container Registry and monitor. You can always monitor your services using Azure Monitor. So, what are the benefits of using all that container thing over VM? Is easy to provision your resources. Um, Cost is light because it's always pay as you go scenario. So it's a platform as a service which is available. You can use that. And last but not the least, scalability, elasticity. It's there. You can scale depending on your workload as required.
Thank you for watching this video. Hope you liked it. If yes, then click the like button and subscribe for our upcoming videos. You can also drop your suggestions and remarks in the comments below. Thank you.